all magnet. Question number 38. Jason set up the following experiment with 3 different liquids in identical beakers. He used the same light sensor to measure the amount of light that passed through each liquid using the same torch. He recorded the data in the table. Now the table, there are 3 liquids A, B, C, and the intensity of the light that was passed through these 3 liquids is 100, 0, 150. Part A. What was the aim of his experiment? So the aim of the experiment is to find out which liquid allows the most light to pass through. Question or statement B. Part B. Give an example of liquid B. Now as you can see, liquid B does not allow the light to pass through it. So it should be opaque. It's not clear liquid, it is opaque. So one good example we could give is milk. Part C. State one variable that Jason needs to keep constant for a fair test. To have a fair test, all the setup must have the same amount of liquid in the beaker. So liquid A, B, C should be of the same amount. Question number 39. Mrs. Tan conducted an experiment using a torch, a wooden cube, and a white screen as shown in the diagram. So in the diagram we could see a torch, a wooden cube, and a white screen. She moved the wooden cube to find out its effect on the size of the shadow formed on the screen. Her findings are recorded in the table. Now, distance x is the distance between the torch and the wooden cube. When the distance is less, or when the torch is kept closer to the wooden cube, the shadow, if you notice, is higher, or it is higher when the torch is in less distance to the wooden cube. But as the torch moves away from the wooden cube more, the height of the shadow also reduces. Now over to each question. Based on the findings, what is the relationship between distance x and the height of the shadow formed on the screen? Now as you can see that the more the distance x, the lesser the height of the shadow. From the table, when the distance was 10 centimeter, height was 30 centimeter. So distance was less, height was more. And as the distance increased, the height started to decrease. So it's more like an inverse reaction. Question B. What can she do to the white screen if she wants to form a smaller shadow? So to form a smaller shadow, we need to move or increase the distance x in order to form a small shadow. Question C. Explain how the wooden cube formed a shadow on the white screen. So this shadow concept is formed when the light is blocked by the wooden cube. So the light from the torch, it travels in a straight line, and when it is blocked by a wooden cube, which is opaque, then a shadow is formed on the other side of the wooden cube. Suggest the height of the shadow formed on the screen if a wooden cube of height 3 centimeter is used, given that distance x is 40 centimeter. So we need to find out the height, the possible height of the shadow formed if the wooden cube has a height of 3 centimeter and distance x is 40 centimeter. From the table we clearly see that when distance is 40 and the height of the shadow is 8 centimeter. Now and the wooden cube height is 4 centimeter. So when we reduce 1 centimeter in the wooden cube and make it 3 centimeter, obviously there is a change in the height of the shadow. So 6 centimeter is a guess, and a lower value to 8 centimeter. So 6 centimeter could be the height of the shadow. Question number 40. Jacob tried to pull a cork from a bottle of vinegar but was unable to do so. His brother suggested heating the top part of the bottle with a flame. So Jacob is heating it up, and suddenly the cork was easily coming out. Jacob was able to remove the stopper easily after heating the top part of the bottle. Now, part A. Explain why Jacob could remove the stopper easily. When you consider the experiment where the flask was being heated by a candle and air had to escape out of the flask because it was expanding. So the similar concept is applied in opening the bottle. Air in the top part of the bottle, when it was heated, it gained heat from the flame and it began to expand, and which made it easy for Jacob to easily remove the stopper. And over to the part B question. Suggest what Jacob can do to the glasses to separate them without breaking them. Explain clearly how your suggestion works. Now, this picture, there are two glass cups that are kept one over the other, and it is stuck. So, what can be done? When we consider heating something, heating a material or a particular object, the atoms within that object begin to expand. So heating cannot be used in this to separate the glass from one with the other, because when we heat it, there are chances for the glass to crack when it expands. The opposite to heat is using ice cubes. So when heat expands, ice cubes, they contract. So in this two glasses experiment, Jacob could put ice cubes into the inner glass so that the glass will lose heat to ice and it contracts. So in the first experiment, the heat expands and the bottle was opened easily. And in the second one, ice cubes were placed in it to contract it, so in order to remove the inner glass out. Question number 41. Joyce wanted to use a thermometer to read the temperature of water. Part A. Order the following steps in reading the thermometer by writing 1, 2, 3 in boxes provided. Now there are 3 statements. We need to find out the correct order. Position your eye at the same level as the liquid in the thermometer. Hold the thermometer upright. Read the marking of the liquid in the thermometer. Usually, first, before we position our eye, we need to first hold it in the right way. So 1 is hold thermometer upright. Next is positioning it. Position your eye at the same level as the liquid in the thermometer. And last one is reading the marking of the liquid in the thermometer. Now, next one. Joyce set up an experiment as shown to find out how the materials of cups A, B, and C affect the temperature of water. What change must Joy make to the setup to ensure a fair test? Now, Joyce is performing a temperature experiment by using cups and thermometer. The change that Joyce needs to make when you compare set A, set B, set C, there is a difference between them. That is, in set B, setup B, the thermometer is not immersed into the water. So by not doing that, the reading cannot be taken in a fair way. So to ensure a fair test, she must put all the thermometers at the same level into the boiling water so that it measures the temperature of the water. The next one is the changes in the temperature of water in the 3 cups were then recorded over a period of time. As you can see, the graph has 3 curves of the readings, cup A, cup B, and cup C. Question C. Which cup is most suitable to store ice cubes? Explain your answer based on the results. Now, if you consider cup A, it was very slow in losing the heat. Cup B was little faster in losing the heat. And cup C was very fast in losing the heat. So cup A is slower. Cup A conducted heat from the water to the surrounding the slowest. This shows that cup A is a poor conductor of heat, showing it could transfer heat the slowest and is thus suitable to store ice cubes. So since cup A cannot transfer heat fast, we can store ice cubes in it so that there is no chance for it to melt fast, as cup A does not allow heat to transfer fast. So that's the answer.